Hi everyone. So in the last lecture we were discussing this third normal form. 3NF we have already seen. Now let's see some questions. So 3NF we have already seen, right? So let me ask you some questions. Let me ask you. This is the first question. In 3NF, can we have transitive dependency? In 3NF, can we have transitive dependency? Tell me. Can we have transitive dependency? Tell me. Can we have transitive dependency in 3NF? In 3NF, third normal form, can we have transitive dependency? Yes, we can have, right? Okay, so yes, possible. So we can have, for example, you can have transitive dependency. There is no problem with transitive dependency. For example, if you have like R, A, B, C, D, okay, then you can have transitive dependency. For example, let's assume AB determines for example, consider this. A determines B, B determines C, C determines D, D determines A. Okay, consider this one. No, not this one. So consider this one. AB, let's assume they determine each other, and A determines C. So this is in 3NF, right? Yes or no? This relation is in 3NF. Why? Because there is no non-prime attribute. In this, there is no non-prime attribute. We do not have any non-prime attribute. So in this relation, there is no non-prime attribute. Okay. So this relation is in 3NF because we do not have any non-prime attribute. So there is no problem. There is no violation of 3NF. But can you notice there is a transitive dependency here? Can you notice there is a transitive dependency? This, look at this. This is a transitive dependency. This, not this. AB goes to C. Can you notice AB goes to C? This is a transitive dependency. AB goes to C. This is a transitive functional dependency. AB goes to C. Okay, because if you notice AB goes to C, AB goes to C, AB determines C. This is a transitive dependency because AB can determine A and A can determine C, and you can notice A cannot determine B. Okay, so this you can clearly see that this is a transitive dependency. But remember, so you can notice AB determining C. This is transitive, but this is not a problem for 3NF. This is not a problem, right? For 3NF, this is not a problem. This is your candidate key. This is your prime attribute. This is your prime attribute and transitive. So this is not a problem. Prime attribute can be transitively determined. Yes or no? Prime attribute can be transitively determined by candidate key. That is fine. Yes or no? So like, okay, let me ask you some true false question. Some true false question. Let me ask you. So the first question, in 3NF, a non-prime attribute can be transitively determined by, okay, can be transitively determined by a candidate key. By a candidate key. Tell me, what about this statement? Is this statement true or false? This is your first statement. Is this statement true or false? So this statement is basically false, right? Because this cannot happen. A non-prime attribute transitively determined by a candidate key. This cannot happen. This can never happen. Okay, in 3NF, this is the problem with 3NF. What about this one? A prime attribute transitively determined by candidate key. A prime attribute transitively determined by candidate key. This is fine. Okay, can be. So this is fine. There is no problem here. Here we don't have any problem. We don't have any problem with the prime attribute is transitively determined or not. Is this clear? Prime attribute is a non-prime attribute. So this means attribute. Okay, here this means attribute. So remember, a prime attribute There is no problem here. A prime attribute can be transitively dependent. There is no problem. Okay, let's see the third statement. A non-prime attribute. Okay, so can be transitively determined by a non-prime attribute. Sorry, can be determined. Okay, just remove this transitive word. Can be determined by non-prime attribute. Can be determined by non-prime attribute. In 3NF, a non-prime attribute can be determined by another non-prime attribute. So this statement is false. This statement is false. This is the problem. Okay, so a non-prime attribute is determined by another non-prime attribute. This is a false. So this cannot happen. Okay, so like this. Anyway, what is the definition, final definition of 3NF? What is the final definition? What is the final definition of 3NF? In 3NF, okay, I can say no non-prime attribute can be transitively determined by any candidate key. Yes or no? By any candidate key. This is the 3NF definition. Okay, so very simple idea. Now, these are the definitions of 3NF. Mavit. So non-prime attribute to non-prime attribute. If you have this type of situation, non-prime attribute is determining another non-prime attribute, then if you have this type of situation, then that relation is not in 3NF. That relation will not be in 3NF. Okay, is this clear? That relation will not be in 3NF. I'm not getting your doubt. Maybe you are asked, you might be asking something else. Okay, so you can ask. Let me ask you one more thing. Let me ask you one more thing. This is my question. Can I say that this type of, remember, this type of partial dependency is a problem? Like, okay, candidate key, sorry. See, candidate key partially determines non-prime attribute. Candidate key partially determines non-prime attribute. Okay, so this is a problem for 2NF, right? If this happens, then this is a problem for 2NF. You know this. If this happens, this is a problem for 2NF. So I can say this is a 2NF violation. You can say this is a 2NF violation. Okay, this is your 2NF violation that we already know. Some candidate key partially determining non-prime attribute. This is a 2NF violation we already know. Now what happens because of this? Because of this, what happens? So you know that because of this happens. Because of this happens. That proper subset of candidate key determining non-prime attribute. This happens, correct? Okay, so because of this happens. They are equivalent. They are equivalent to each other. Okay, now again, now you tell me, what about this one? Just look at this proper subset of candidate key. Is it a super key? Is it a super key? This is not a super key. This is not a super key. This is not a super key, correct? Not a super key is determining non-prime attribute. Not a super key is determining non-prime attribute. So this is a problem for what? This is a problem for what? So you can notice this is a 2NF violation. So this is a problem for 2NF. I can say this is a problem for 2NF. This is equivalent to this. So this is also 2NF violation. So this is also 2NF violation. Okay, this is equivalent to this. This is also 2NF violation. And you can notice that this is 2NF violation. This is 3NF violation also. Can you notice this is 3NF violation also? Yes or no? Now this is 3NF violation also. So can I say that 2NF violation implies 3NF violation? If you have 2NF violation, then automatically you have 3NF violation, right? Yes or no? If you have 2NF violation, then automatically you have 3NF violation. So I can say that, so If no, okay. And what is the, tell me. So this is the idea, very simple. What is the contrapositive? What is the contrapositive? The contrapositive. What is the contrapositive? The contrapositive, if you are in 3NF, there is no 3NF violation, then there is no 2NF violation. So I can say that if a relation is in 3NF, so if a relation is in 3NF, then it is in 2NF also. Then it is in 2NF also. Is this clear? Then it is in 2NF also. Okay. So this is the idea. Now, so now let's move on. Let's see this one. Is this a different question or same question? I think this is the same question. Okay. So let's forget about this one. Let's forget about this one. Let's see something else. Yeah. Okay. So this is a different question. This is a different question. Now let's check it out. Let's take your copy pen. Let's do some exercise for 3NF. The question is all about 3NF. So let's do some practice. So tell me, what will be the answer for the first one? For the first one, what will be the answer? Is this in 3NF? See the first one. What about the first one? B determines C. So first of all, what are the candidate keys? You find what are the candidate keys. So B determines C. C, D, C, A. So B. Okay, just check what is B plus. Check what is B plus. Let's do some practice. Check what is B plus. B plus is BC. That's it. Okay, B plus is BC. So what is the candidate key? So candidate key can be, for example, what about BD? So BD, if you notice BD plus will be BDCA. Okay, so this will be the BDCA. Next, so this is definitely a candidate key. So if you see the candidate key, then BD is a candidate key. What else? What about CD? What about CD? Sorry, CB. CB is not a candidate key. CB is not a candidate key. Okay, what else? CA. Sorry, BA. What about BA? What about BA? So BA will be BCA. BCA. Okay, and that can return. Okay, so this is also. So you can notice AB. This is also candidate key. These are the candidate keys. So anyway, what is the non-prime attribute? Tell me what is the non-prime attribute. B. Okay, so non-prime attribute is C. C is the non-prime attribute. Now you tell me, is this in 2NF? What is the method 1? Sorry, is this in 3NF? Is this in 3NF? What is the method 1? Just check. Okay, just check. Is this in 3NF? So you can notice this is C. This is the non-prime attribute. This is the non-prime attribute. This C. This is the only non-prime attribute. So this type of thing you cannot have. Non-prime to non-prime. Yes or no? Non-prime to non-prime you cannot have. Correct or not? Because only non-prime attribute is this. Only one non-prime attribute you have. There is only one non-prime attribute. So which type of violation you will look for? Tell me which type of violation you are looking for. You are looking for not a super key implies C. Not a super key implies C. This is not a super key. Not a super key. This is not a super key. Not a super key implies non-prime attribute. Yes or no? Is this clear? Very simple. Not a super key implies non-prime attribute. So this is the violation. So I can say, so not in 2NF. Sorry, not in 3NF. So it is not in 3NF. Is this clear? Let me know. So this is not in 3NF. This relation. What about 2NF? What about 2NF? This relation R. What about 2NF? Do we have proper subset? Yes, you can notice this B goes to C. You can notice, so not 2NF. So not 2NF also. This is the violation. Yes or no? This is the violation. Proper subset of candidate key. Proper subset of candidate key. determining non-prime attribute. So this is not 2NF also. So this is not 3NF, not 2NF. What about 1NF? What about 1NF? So this is in one normal form. That will always happen. That will always happen. Okay, what about, so this is the idea. Now, actually you can notice there is a transitive dependency. So you can notice there is a transitive dependency because you can, I can say that this BD determining C, this is a transitive dependency. Yes or no? BD determining C, this is a transitive dependency. You can clearly see this is a transitive dependency. Yes or no? This is a transitive dependency where this is a candidate key, where this is a non-prime attribute. So this is the problem. So this is the problem. This is a transitive dependency. Why this is a transitive dependency? Tell me why this is a transitive dependency. Because BD can determine B, that can determine C, and B cannot determine BD, and B cannot determine BD. Yes or no? So picture perfect. You can notice. Okay. So this is your perfect photo you got. So this is your transitive dependency. So candidate key transitively determining non-prime attribute. Candidate key transitively determining non-prime attribute. So this is a, I can say, so definitely this is not 3NF. Okay, so what is happening here? You can clearly see what is happening here. So I can say that here what is happening. So candidate key is transitively determined non-prime attribute. Okay, transitively determining non-prime attribute. And hence this is a problem. So not 3NF. Okay, so this is quite easy. Now let's see the option number B. What about option number B? Tell me, what about option number B? What is the candidate key? C, C, D, D. So AB, just check it out. The candidate key will be, I think, AB. It will be AB. AB can determine AB. AB can determine C. Okay, AB can determine C. ABC can determine D. ABC can determine D. So this is your candidate key. So your candidate key is this. Check for 2NF. Is this relation in 2NF? Just check for 2NF. This relation. This relation, is it in 2NF? What is A plus? A plus is A. What is B plus? B plus is B. So this is in 2NF. You can notice in 2NF. This relation is definitely in 2NF. Yes or no? Because the subset of candidate key, you can notice the subset of candidate key is A plus is A and B plus is B. So this is in 2NF. Agree? Okay. So this is very simple. Now, why this is in 2NF? Is this clear to everyone? Please tell me. Please tell me why this is in 2NF. Is this clear to everyone? This is in 2NF because this can never happen. This can never happen. Subset of candidate key determining non-prime attribute, this can never happen. This can never happen. Subset of candidate key determining non-prime attribute, this cannot happen. Not possible. So this relation is not in 2NF. Sorry, this relation is in 2NF because this is not possible. So 2NF. What about 3NF? What about 3NF? So this is in 2NF. Now what about 3NF? So here again you can notice that non-prime attribute. Can you determine non-prime attribute from a non-super key? From not a super key. From not a super key. Is this a super key? AC. Tell me, is this a super key? AC. AC. Is this a super key? Is this a super key? This is not a super key, right? This is not a super key. So not a super key determining non-prime attribute. Not a super key determining non-prime attribute. Is this clear? Not a super key determining non-prime attribute. So not 3NF. Is this clear? Not a super key determining determining non-prime attribute. This is not a super key, and this is determining non-prime attribute. So this is the problem with 3NF. What is the method 2? Method 2 is transitive dependency. Okay, can you create this type of transitive dependency? Can you create this type of transitive dependency? This type of transitive dependency? Yes, we can create. I can say that AB determining AC determining D. Can you notice? This does not determine this. So this is your perfect photo. So I can say that AB determining D is a transitive. This is a transitive. AB determining D, this is transitive, where this is candidate key and where this is a non-prime. Where this is candidate key and this is non-prime. Tell me, is this clear? Okay. So this is another method. Another method. So you have this type of transitive dependency. Yes, correct. So this type of transitive dependency you have. Yes. So not 3NF. What about the third one? What about the third one? What about the third one? So what about this one? What is the candidate key? Tell me what is the candidate key? A, B. So basically D must be there. D must be there. So, but D alone is not enough. What about AD? AD can, A can bring B, ABD. Okay, so AD. Yeah, that is fine. AD is there. What else? What about BD? BD is also there. BD also will be there. Okay. What about CD? What about CD? CD. CD is not a candidate key. CD is not a candidate key. Okay, so these are the candidate keys. So tell me, what is the non-prime attribute? What is the non-prime attribute? AD, BD. So C is the non-prime attribute. Okay. Now you tell me, is this in 2NF? Is this relation in 2NF? This relation, is it in 2NF? Can a proper subset, can a proper subset determine C? Can a proper subset of candidate key determine C? Are how many proper subsets are there? Just check. Are how many proper subsets are there? Just check all of them. Just check all of them. What is A plus? A plus is ABC. So yes, A can determine C, right? A plus is ABC. A plus is ABC. So A can determine C. So A can determine C. Okay, this is violation of 2NF. This is violation of 2NF, right? This is violation of 2NF. Tell me why this is violation of 2NF. This is violation of 2NF. So not 2NF. So not 2NF. What is the method number 2? What is the method number 2? Method number 2 is, this is a candidate key. Method number 2 is this. AD determines C. This is partial. Why this is partial? So this is candidate key. This is non-prime attribute. This is candidate key. This is non-prime attribute. And this is partial. And you can notice this is a partial because A can determine C. So you can notice that this is partial dependency. AD is determining C. This is partial dependency. So not 2NF. This is not into NF. If something is not into NF, if it is not into NF, then it is not in 3NF. So this is not into NF. If something is not into NF, then it implies not in 3NF. If something is not into NF, then it is not in 3NF. So this is not in 3NF. But what is method number 2 for checking what is the violation of 3NF? Where is the violation of 3NF? Tell me, where is the violation of 3NF? The same violation will work, or you can give some other violation. The non-prime attribute is C. So you cannot give non-prime to non-prime. Nikhil, you cannot give non-prime to non-prime because there is only one non-prime attribute. There is only one non-prime attribute. Are the same violation will work? The same violation will work or not? This is also violation. AB determining C, this is also violation. Can you notice this is violation? This is violation because this is not a super key. This is not a super key. Correct? This is not a super key. And this is non-prime. And this is non-prime. So this is a violation of 3NF. What is another violation of 3NF? What is another violation of 3NF? The same. The violation of 2NF is also violation of 3NF. The violation of 2NF is also violation of 3NF. This is also violation of 3NF because this is not super key. Because this is not super key and this is non-prime. So this is also violation of 3NF. The violation of 2NF is also violation of 3NF. Where is the transitive dependency? Where is the transitive dependency? Where is the transitive dependency? I can say that AD can determine A, it can determine C. So you can notice this is a transitive dependency. So there is a transitive dependency. You can notice that AD is transitively determining C. Is transitively determining C. Okay, so this is the transitive dependency. Now let's move on. Tell me about the so this third one. This is a violation of 3NF. What about the last one? What about option D? Tell me, what about option D? What is the candidate key for option D? A, check A because A is not on right side. So check A plus. A plus is only A. Okay, so let's check AC. Let me check AC. So what is AC plus? That will be ACD, and AC can determine B. So AC is there. A must be there. C, and you can notice AD is also there. What about AB? What about AB? AB is not a candidate key. AB is not a candidate key. So what is non-prime attribute? So what is non-prime attribute? Non-prime attribute is a C. Sorry, B. Non-prime attribute is B. Is there any problem here? What about 2NF? What about 2NF? So let's check 2NF. Let's check for 2NF. So this is your non-prime attribute. Can a proper subset of candidate key determine this B? Can proper subset of candidate key? Can proper subset of some candidate key determine B? What are the proper subsets of candidate key are there? Tell me. How many proper subsets of candidate key are there? How many proper subsets of candidate key are there? There are three. There are three. Okay, tell me, can A determine B? Can C determine B? Can D determine B? Just tell me this point. Just tell me this point. Can A determine B? Can A determine B? No. Can C determine B? Can A determine B? No. Can C determine B? No. Can D determine B? So no. 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 So what it means? So it means there is no violation. So in 2NF. So the relation is in 2NF. 2NF is quite easy actually. Just check all the proper subsets. Yes or no? Is this clear? Array, just check all the proper subsets. Just to check all the proper subsets. Just to check all the proper subsets, nothing else. And this is the non-prime attribute. All the proper subsets of candidate key you check. What about 3NF? So this is in 2NF. What about 3NF? Tell me. Yuvraj, it's just all about understanding. Once you understand, you will never forget all these things. Just work it out. Okay. Take copy pen and just work it out. Yes, proper subset can contain multiple attributes. Mavit, yes, proper subset can contain multiple attributes. Okay. Now tell me about 3NF. So this is in 2NF, 3NF. Tell me. So can you create, okay, can a non-super key, can it determine B? Can a non-super key determine B? Can a non-super key determine B? This is your, so can a non-super key determine B? Okay, so tell me, can a non-super key determine B? So you can notice this is a super key. Can a non-super key determine B? This is what we are checking. Can a non-super key determine B? So single attribute cannot determine B. In the double attribute, what are the non-super key? Not containing B, because don't worry about trivial dependency. Don't worry about trivial dependency. What about CD? Can CD determine B? No, CD also cannot determine B. CD also cannot determine B. Okay. So what about three attributes? So yes, this is not 3NF. This is not possible. Non-super key determining B. This is not possible. This is not possible. So 3NF. Is this clear? Why this is not possible? Tell me. Tell me why this is not possible. Just check. Just check what are the non-super key. Just check what are the non-super key. You can notice that. And remember, not containing B, because if it contains B, then what will happen? Tell me. If it contains B, then what will happen? If it contains B, then what will happen? It will become trivial dependency. It will become trivial dependency. So how many non-super key you have to check? Basically containing only A, B, C. So single attribute you can check. Single attribute is not determining B. And double attribute, this CD is also not determining B. So there is no problem. Okay. So you don't have any such a problem. Not possible. So this relation is in 3NF. Okay. So this is what we have done. Anyone has any doubt? Let me know. Please tell me. Anyone has any doubt in the 3NF, in third normal form? Mavit is asking, sir, can we say that attributes are present in LHS of all FD, then it is non-prime attribute? If attribute, can we say that attribute not present in LHS? If it is not present in LHS, if some attribute is not present in LHS, then no, Mavit, you can easily create the counterexample for your statement. For your statement, you can easily create the counterexample. Consider this R, A, B, C, D, and consider this dependency. What are the prime attributes? Tell me what are the prime attributes? What are the prime attributes and what are the non-prime attributes? So non-prime attribute is actually B only. Is this clear? Mavit, is your doubt clear? Non-prime attribute is B only. You are saying that if some attribute is not present on LHS, then it is, if some attribute is not present on LHS, then it is a non-prime, but it is not true. These are actually prime. Tell me, Mavit, is your doubt clear? Let me know. Tell me. No, but you are saying, but Mavit, you are saying that if it is not present on LHS, but you cannot C, D are also not present. C comma D are also not present, but they are prime. Okay. So don't make such conclusions. Okay. Is this clear? C comma D are also not present on LHS. On LHS, C comma D are also not present, but they are prime. Okay, let's move on. What about this one? Is this in 3NF? Is this relation is in 3NF? So can I give this as a homework? Okay, so take this as a homework. Let's take this also as a homework. Okay, take some questions as a homework. Can converse of the statement is true? Which converse, Mavit? At the end you ask. Okay, your doubt you can ask at the end. You can speak and you can ask. So let's see the next. That is BCNF normal form. What is BCNF? This is Boyce code normal form. First of all, what is BCNF? BCNF. What this means? This B means Boyce. It was given by two people. Boyce code normal form. Boyce code normal form. Okay. So this is a, I told you, this is another research paper. So this was given in another research paper. And this is the most simple normal form. This normal form says that every non-trivial functional dependency, LHS must be super key. Okay, this is extremely simple. This says that every non-trivial functional dependency, LHS must be super key. Okay, so what is BCNF? A relation is in BCNF if whatever functional dependency you take, LHS must be super key. Is this clear? This is very simple. This BCNF, what it says that a relation is in BCNF, a relation R is in BCNF, if and only if for all FDs, for all non-trivial FDs, for all non-trivial FDs, what should happen? For every non-trivial FD, what should happen? For every non-trivial FD, you take any non-trivial FD, X goes to A or X goes to Y, whatever. So you take any non-trivial FD, okay? For all non-trivial FD, X must be super key. This X must be super key. Is this point clear? Very simple definition. This is the most simple definition, that just check the LHS. Just check LHS of every non-trivial functional dependency. Every non-trivial functional dependency, just check the LHS. It should be super key. This is your Boyce code normal form. Tell me one thing. What makes a relation in 3NF but not in BCNF? What makes a relation in 3NF but not BCNF? See, BCNF is saying that, remember this BCNF, what this BCNF is saying, the BCNF, what this BCNF is saying, this BCNF is saying that this should be super key. BCNF is saying that this should be super key. BCNF is saying that this should be super key. What 3NF is saying? What 3NF is saying? Tell me what 3NF is saying. 3NF is saying that either this should be super key or this should be prime attribute. Yes or no? Either this should be super key or this should be prime attribute. Yes or no? 3NF is saying that this is super key and this non-prime. This should not happen. Agree or not? See, very simple point. What 3NF is saying. Look at what 3NF is saying. 3NF is saying that this should not happen. This should not happen. What should not happen? This should not happen. Like not super key implies non-prime. Agree? Yes or no? So this should not happen. 3NF is saying that this should not happen. So what should happen? So what should happen? So what should happen? If you have X determining A, non-trivial functional dependency. If you have non-trivial functional dependency, This is saying this should not happen. So what should happen? This should not happen. This should not happen. So what should happen if you have non-trivial functional dependency? So it should happen that either this should be super key or this should be prime. Agree? Either this should be super key or this should be prime. Agree or not? Correct? This should happen in every non-trivial. What should happen in every non-trivial functional dependency? This should happen. So what I'm asking that BCNF is saying that this should be super key, and 3NF is saying that either this should be super key or this should be prime. Okay. In which condition you will get? See, first of all, can I say every BCNF is 3NF? Can I say every BCNF is 3NF? So R in BCNF implies if your relation is in BCNF, automatically it is in 3NF. Automatically it will be in 3NF. If your relation is in BCNF, if your relation has this, tell me. If your relation has this, then automatically your relation has this also. Because 3NF is saying that either this should be super key or this should be prime. So if this happens, then 3NF is happy. If this happens, then 3NF is very happy. Correct? So you can notice that if R is in BCNF, then R is in 3NF. Okay, tell me, when this will happen? When this will happen, that not in 3NF, but not in BCNF. When this will happen? In 3NF, but not in BCNF. From this you see, what type of FD should you have? So basically, we must have, so there exists a FD, there exists a non-trivial FD. Tell me what should happen? It should happen, there exists a non-trivial FD. There exists a non-trivial FD where what will happen? Where this is not a super key. There exists a non-trivial FD where this is not a super key. Correct? And this is a prime, because it must be in 3NF. It must be in 3NF. It must be in 3NF. So can I put non-prime here? Can I put non-prime here? Tell me. If I put this, now what will happen? Tell me now what will happen if I put this? If I put this, now it is not in 3NF. If I put this, now it is not in 3NF. If I put this, now the relation is not in 3NF and not in BCNF. Correct? So what should happen? Tell me. Is this clear? Please see. This is very easy concept. This is the condition for BCNF. This is the condition for 3NF. When it will happen that you don't have BCNF, but you have 3NF. When it will happen? You have 3NF, but not BCNF. Tell me when it will happen. When you don't have BCNF, but you have 3NF. You should not have BCNF. What it means? One by one I am asking. You should not have BCNF. What it means? It means it should not be super key. It means it should not be super key. It should not be super key. It should not be super key. It should be in 3NF. Now it should be in 3NF. So what should happen? It should be in 3NF. So what should happen? This should be prime attribute. Okay, this should be prime attribute. Like, correct? Okay, so very simple. So this should be prime attribute. So tell me, is this point clear to everyone? So this is what I'm saying, that there exists a non-trivial FD where non-super key determines prime attribute. Non-super key determines prime attribute. Then your relation is in 3NF, but not in BCNF. Okay, now let's solve some questions. So your chapter is over. We have seen everything. Now we will see some questions, and I will again, all the important points I will again tell you. Okay, shall we do it? Now we will solve some gate questions, some nice gate questions we will solve. And with these gate questions, I will again, all the important points again I will tell you. Okay, so Anyway, let's solve this question first. This is not a GATE exam question, but tell me what is the answer here. What should be the answer here? A, B, C, D, E, F. So first you find what are the candidate keys. What are the candidate keys? So you can notice A, B, C, D, E, F. So just check AD. What AD can bring? Because AD is not on RHS. AD is not on RHS. AD is not on RHS. So what AD will bring? AD can determine AD. It can determine A can bring BC. A can determine BC. C can determine F. C can determine F. And this D can determine E. This D can determine E. So this is your candidate key. So only candidate key is A, B. So what are the non-prime attributes? So what are the non-prime attributes? So those are basically, I can say B, C, E, F. These are the non-prime. Is this in first normal form? Yes. There is nothing to check. Is this in first normal form? Yes. Next, what about second normal form? What about C? Okay, see BCNF. Let's check for BCNF because that is easy. Because this is very easy. Let's check for BCNF because this is very easy. So let me check for BCNF. What about BCNF? This is the violation. See, okay, this is the violation. See, BCNF is very easy, right? Yes or no? BCNF is very easy. BCNF says that super key must determine everything. Whatever you put here. Whatever you put here. Non-trivial, every non-trivial FD must be like this. Every non-trivial FD must be like this. Every non-trivial FD must be like this. Now you can notice this is the violation because this is not super key. This is not a super key. So this is a violation and this is non-trivial FD. And this is a non-trivial FD. So this is the violation. So not in 3NF, BCNF. So we can say this is not in BCNF. What about 3NF? 3NF. What about check 3NF? Check 3NF. Why I am going in the reverse direction? Anyone want to tell me? Anyone want to tell me why I am going in the reverse direction? First BCNF, then 3NF, then 2NF. Why? No, because if we get, see, just think about it. If we get the answer is 2NF, if we get the answer 3NF, then we can stop. If your relation is in 3NF, if your relation is in 3NF, then it is automatically in 2NF. Then we can stop. So if your relation is in 3NF, we can stop because your relation will definitely be in 2NF. The second point, they will ask you the highest normal form. What they will ask you? They will ask you the highest normal form. Like 1NF, 2NF, like I can say 1NF is lowest, 1NF is lowest, 2NF, 3NF, BCNF. So they will ask you highest normal form, they will ask you. So always go in the reverse direction. The third point, what is the third point? Checking BCNF is easy. Checking 3NF is easier than 2NF. So basically BCNF is very easy, 3NF is easy, and 2NF is a little bit, I can say it will take some time. Okay, so let's see this. So now you can notice, check for 3NF. Check for 3NF. What is the violation? Can you notice this is the violation? This is the violation. Non-prime, non-prime. So you have violation because it is non-prime. It is non-prime to non-prime. So or I can say this is a, or I can say this is not super key. This is not super key and this is non-prime. So this is the violation. Correct? This is the violation. So I can say this is not in 3 normal form also. Okay. And now one more thing. What about 2NF? What about 2NF? To second normal form. So check proper subset of, this is what you check. Proper subset of candidate key. What are those? Tell me how many proper subsets are there? Tell me how many proper subsets are there of candidate key? This is a proper subset. This is a proper subset. So tell me, what is A plus? What is A plus? Just find out what is A plus. A plus is ABC, and that's it. And that's it. So you can say non-prime. So here you can stop. So this is not into enough also. So your answer will be what? So your answer will be one. That will be 1NF. Is this clear? Your answer will be 1NF. Okay. So in this question we have done everything. In this question, B plus will be B. Tell me, in this question, one more thing I want to ask you. In this question, can you notice that in 2NF, I told you that okay, this is my question. In 2NF, every non-prime attribute, sorry, this is my question. If R is not into enough, if R is not into enough, then some non-trivial, then some non-prime attribute is partially dependent on all candidate keys. Is this clear? Tell me, is this true? Is this statement true? Look at this statement. Is this statement true? If relation is not into enough, then some non-prime attribute is partially dependent on all candidate keys. Is this statement true? This statement is false. Why? This statement is false. Because very simple. You can very easily see this statement is actually false. And why this statement is false? The reason you can see here. In this example, you can see this is not into enough. You can see this example. In the previous example, you can notice. So, okay, in previous example, what you can notice? In previous example, you can notice that every on B, every non-prime attribute is fully dependent on B. Yes or no? Can you notice? If you notice every what I'm saying, sorry, what I'm saying here, actually there is only one candidate key. So actually this, no, because so no, previous example you cannot take, because there is only one candidate key. Because there is only one candidate key, so this previous example you cannot take, because there is only one candidate key. There is only one candidate key, so this example you cannot take. Okay, but anyway, this statement is false because of this reason, because of this word. This statement is false because of this word. Some example you can definitely you can create. Some example you can create. Okay, maybe you can try some example you can create, but because of this word. So this will be true. This will be true. If I put some here, now this will be true. Now this statement will be true. Okay, let's move on. So what about this one? Can I give this as a homework? So take this question as a homework. Okay, check everything in this question. Let's see the next question. This is your GATE exam question. Tell me, what is the answer? This is GATE exam, GATE 2005 question. So some fields are given to you. Field means attribute. So some attributes are given to you, F1 to F5. These are the attributes with the following functional dependencies. These are the functional dependencies. In the terms of normalization, the table is in. Basically, your answer must be highest normal form. This is MCQ question. Okay, this question is MCQ. So if this is MCQ, your answer must be the highest normal form. Next, tell me what is the answer. So these are the these are given. First of all, you find the candidate keys. So tell me what are the candidate keys here. So you can notice F1 is not on RHS. Look, F1, F2 are not in RHS. F1, F2, they are not available on RHS. So F1, F2 are not present on the RHS of any functional dependency. These F1, F2, they are not present on the RHS of any non-trivial functional dependency. So they must be part of every candidate key. They must be part of every candidate key. What they can determine? F1, F2. What they can determine? So they can determine F1, F2. They can also determine F5. They can also determine F2 can determine F4. And you can notice F1 can determine F3. So basically, this is the candidate key. So what I can say in this question, in this relation, in this table, I can say in this table, this F1, F3, this is the only candidate key. This is the only candidate key, this F1, F3. So only one candidate key. Now, can you notice this is not in 2NF? Now, this relation is not in 2NF. Why? What is the violation? So this relation is not in 2NF. Why? The relation, because you have this type of partial dependency. Look at this partial dependency. F1, F3 determining F1, F3 determining, I can say, so sorry, F1, F2. F1, F2. F1, F2 is the only candidate key. This F1, F2 is the only candidate key. This is the candidate key, F1, F2. So you can notice that this is the violation. Look at this transitive dependency. Look at this transitive dependency, F1, F2 determining F4. Determining F4. Is this a partial dependency? Tell me. Is this a partial dependency? Yes, this is a partial dependency because you can remove F1. Because you can remove F1, so this is a partial dependency. So this is your partial dependency, and you can notice this is a candidate key, and this is non-prime attribute, and this is non-prime attribute. So I can say that candidate key is partially determining non-prime attribute. So that is the reason this is not in 2NF. Okay, so that is the reason this is not in 2NF. So you can notice this is not in 2NF. So it is also not in 3NF, not in BCNF. Okay, so this is not in. Is this clear? So this is not in 2NF. This is not in, so the answer will be 1NF. Okay, yes or no? What is the another method? What is the another method? You can check proper subset. The method number 2. You can check this. You can check proper subset of candidate key. You can check proper subset of candidate key. Does it determine non-prime attribute? Does it determine non-prime attribute? Tell me how many proper subsets are there. Just tell me this point. How many proper subsets are there? Only 2 proper subsets are there, F1, F2. Find what is F1 plus, what is F2 plus. What is F1 plus? What is F1 plus? F1 plus is F1, F3, F1 plus is F1, F3. So here you can stop. Here you can stop. So this is a non-prime attribute. So you can notice. So basically F1 is determining F3. This is the violation of 2NF. This is the violation of 2NF. Tell me, is this partial dependency? F1 to F3. F1 determines F3. Is this partial dependency? This is full dependency. This is actually full dependency. This is not partial. This is not partial. What is partial? This is partial. F1, F2 determining F3. This is partial. This is partial, where this is candidate key, and this is non-prime attribute. And this is non-prime attribute. Okay, is this clear? So this type of partial dependency is the problem. So your answer will be, for this question, answer will be option A. Okay, let's see this question. Tell me what is the answer. The question is saying that a relation R with the schema X, Y. So you have a relation R with the schema X, Y. You have a relation R and the schema is X, Y. Satisfies the functional dependency X goes to Y. X determines Y. X determines Y. The tuples can be both simultaneously in R. So remember what this means. Just tell me what this means. When you say that X determines Y, what this means? This means that whenever x and y are same, two tuples, when they have same value of x, when two tuples have same value of x, if this happens, remember, if this happens, then this will happen. What will happen? They will have same value of y. If two tuples have same value of x, they will have same value of y. Okay, if two tuples have same value of x, they will have same value of y. Tell me, if this is false, if two tuples have different value of x, now then if two tuples have different value of x, then we don't care. Then may or may not. Yes or no? Then may or may not equal to yes or no. Very simple. X determines y. What it means? That if two tuples, if okay, these are different. If these are different, then T1 may or may not be equal to T2. Then T1y may or may not be equal to T2y. Now we don't care. In this situation, we don't care. So very simple. X is determining y. So can we have 1, 2, 2, 2? There is no problem, right? There is no problem because you can notice these two, the value of x is different. So the value of y does not matter. So everything is fine. Remember x comma y, 1, 2, 2, 2, 3, 3. Okay, everything is fine. All these things are fine. Is this clear? So this is a very simple question. So is it true or false? So this is a true. This is true. These are allowed. They can be both present simultaneously. Simultaneously, they can be present. Remember, this is the simple point. If you have some attribute A determining B, please understand that you have A, B, then what will happen? Whenever you repeat, for example, something else can be here. Here you can have something else. But the point is, whenever you repeat this, like let's assume this is 2, this is 3. Now, whenever you repeat this, it will repeat. When you repeat this, it will repeat. But if you change it, then it may repeat, it may not repeat. It may repeat, it may not repeat. Now, when you repeat this, it will repeat. It will repeat. Now, when you change this, it may or may not repeat. But when you repeat this, it will repeat. So this is the idea. Okay, let's see the next. This is the question I was talking about. This is a nice question. GATE 1990 question. GATE 1990 question. See, those students who have already studied from somewhere else, many students, they think like this. See, I have seen this is a misconception. Now I am going to take some really nice GATE questions. These are the misconceptions. That 2NF doesn't have partial dependency. 2NF doesn't have partial dependency. Okay, 2NF doesn't have partial dependency. This is a misconception. 2NF doesn't have partial dependency. 3NF doesn't have transitive dependency. 3NF doesn't have transitive dependency. Doesn't have transitive dependency. These are misconceptions. Okay, these are misconceptions. These are wrong. Is this clear? Now you might be thinking, see, let me tell you, these are wrong. Okay, now let me tell you one thing. Many students, many students in the last 20 years, maybe 15 years, last 20 years, you can check on the GATEOverflow website, you can check in the Telegram groups, you can check their notes. Okay, many students who are learning from many different, I can say non-standard resources. Okay, so they have these misconceptions. Now let me tell you one thing. There are GATE questions using which they can clear their misconception, but still I don't know how they are solving these questions. For example, this is what they will say. They will say, okay, 2NF doesn't have partial dependency, 3NF doesn't have transitive dependency. This is what they will say. But now you can notice, for this question, what will be your answer? For this question, what will be their answer? Tell me, this is the question. Which of the following is false? This is MCQ question. Which of the following is false? Tell me. Which of the following is false? Then they will say that. Which of the following is false? Read this, read the options. First, let's solve by our correct concepts. First, apply your correct concepts. Let's apply your correct concepts. So, okay, just apply your correct concept. This is the question. Let's apply. This is the question. Let's apply all the correct concept that you have seen, you have studied. Any relation with the two attributes is in BCNF. Can I say? Can I say is this in BCNF? If a relation has two attributes only, then can you create? See, what are the possibilities? If your relation has two attributes only, what are the possibilities? Tell me, what are all the possibilities? If your relation has two attributes, then what are the possibilities of non-trivial FDs? What are the possibilities of non-trivial FDs? What are the possibility of non-trivial FDs? What are the possibilities? The first possibility is no non-trivial FD. The first possibility is non-trivial FD. If you don't have non-trivial FD, then there is no problem. Yes or no? Correct? If you don't have non-trivial FD, then there is no problem. If there is no non-trivial FD, in this situation, what will be the candidate key? If you have no non-trivial FD, if there is no non-trivial FD, in this situation, what will be the candidate key? That will be AB. So if you have no non-trivial FD, there is no problem. Correct? In this situation, can you have, tell me, if there is no non-trivial FD, if there is no non-trivial FD, what will be the candidate key? Can it be A? Can I say it will be A? Can I say it will be A? Can I say it will be A? What is wrong here? If you say it is A, then why? What is the answer? If you say it is A, then what will happen? If you say it is candidate key, then it means A determines B. This is non-trivial FD. Is this clear? Tell me. If you say this is non-trivial, if you say this is candidate key, then A determines B, which is non-trivial FD. So this cannot happen. Can I say this? The same logic. This also cannot happen. What about this? This is correct. Okay. So in this situation, candidate key will be AB. So if you don't have any non-trivial FD, no problem. Your relation will be in BCNF. There is no violation. No BCNF violation. Second point, if you have A determining B, then also there is no problem. Then also it is in BCNF. Third, B determining A, then also BCNF, there is no problem. Then it is BCNF. And the fourth, A determining B, B determining A, then also BCNF. So there is no violation. So if you have two attributes, then it will be in BCNF. Your relation will be in BCNF. So this is actually true. This statement is actually true. What about the second? What about the second? A relation in which every key has only one attribute. In which every key has only one attribute. Key means what? Tell me, key means what? This word key, this means what? Key means candidate key. So if every candidate key has one attribute, then if every candidate key, has one attribute, then this is also true. Then it is in 2NF. Because now you cannot create a partial dependency. Now you cannot create a partial dependency where candidate key determines non-prime attribute. Now you cannot create proper subset of candidate key. In this situation, you cannot create proper subset of candidate key. What about the next one? What about option C? A prime attribute can be transitively dependent on a key in 3NF. No problem. It is fine, right? We don't have any problem. Yes or no? Prime attribute can be transitively dependent. There is no problem. Prime attribute can be transitively dependent. So this type of transitive dependency can be there. Agree or not? This transitive dependency is fine. This transitive dependency is fine. Agree? So this transitive dependency is fine. We have already seen this. This transitive dependency is fine. This transitive dependency is allowed in 3NF. At this point, can you notice? Okay, just wait now. Now, can you notice those concepts like 3NF does not have transitive dependency? Those concepts are wrong. Can you notice? This gate question is saying that those concepts are wrong. Please read this question and tell me. Those concepts are wrong, right? When someone says 3NF cannot have transitive dependency, 3NF cannot have transitive dependency, those concepts are wrong. The gate question itself is telling you yes or no. So there is a gate question which is shouting that your questions are wrong, your concepts are wrong. There is a gate question which is screaming like your concepts are wrong. Still students are learning the same wrong concepts. Like, let me tell you, I don't understand how they are solving this question. For last say 7 years they are solving this question. So this is 2007 question. This is 2007 question. For last maybe almost for last 15 years people are solving these questions. I don't know how they are solving this question, because many students, majority of the students, they have misconceptions, and using those misconceptions you cannot solve this question, right? Yes or no? Okay, anyway, so basically this transitive dependency is fine. You can take example. You can take the example for 3. See, consider this example. Consider this example. Let me tell you actually what happens. It happens that once you get the right answer, basically what many students do, this is a problem with many students. What they do, once they get one option, like, okay, once they get, for example, once they get this is false, then they don't care about the remaining. Once the question is asking false, this is false, so I don't care about the remaining. I don't care about this. So this is the problem with many students. So you should not do this. Anyway, so let's see this third one. Tell me, can you give me a relation 3NF which has transitive dependency? Consider this relation R, A, B, C, D, where AB determines CD, CD determines A, and A determines C. Can you notice this is in 3NF? Sorry, this relation. Tell me, is this relation in 3NF? Because there is no non-prime attribute. This is in 3NF. Why? Because there is no non-prime attribute. There is no non-prime attribute. So because there is no non-prime attribute, so automatically this is in 3NF. Okay, now you tell me, do we have transitive dependency? But this is the transitive dependency. Look at this. This is the transitive dependency. AB determining C. This is your transitive dependency. This is your transitive dependency. Here, in this transitive dependency, what is happening in this? In this transitive dependency, what is happening? AB determining C. This is transitive dependency. Notice. Why this is transitive dependency? Because AB can determine A. AB can determine A. A can determine C. A cannot determine B. So this is a transitive dependency. So I can say this AB determining C is transitive. Is transitive dependency. Can you notice? So I can say this is a candidate key. This is the prime attribute. So a prime attribute can be transitively dependent on key, yes or no? Agree or not? See this. So a candidate key, a prime attribute can be transitively dependent on candidate key. A prime attribute can be transitively dependent on candidate key. This is what I'm saying. So in 3NF, a prime attribute, the relation is in 3NF. So in 3NF, a prime attribute can be transitively dependent on candidate key. Can be transitively dependent on candidate keys. Can be dependent on candidate keys. Is this clear? So a prime attribute, we don't care about prime attribute. A prime attribute can be transitively dependent on candidate keys. It can be. So this is your option number C. What about option number D? What about option number D? A prime attribute can be transitively dependent on key in BCNF. In BCNF, a transitive, it can, okay, so this is not possible. Why this is not possible? Tell me why this is not possible. This is not possible because every non-trivial FD LHS is super key. Why this is not possible? Notice that in BCNF, very simple point, in BCNF, every, this is very important. Every non-trivial FD, if you take any non-trivial FD, so any non-trivial FD, what will happen? Every non-trivial, every non-trivial FD, in every non-trivial FD, LHS is super key. Okay, LHS is super key. So can you have transitive dependency? Can you create transitive dependency? This is my question. In BCNF, can we have candidate key transitively determining some prime attribute? Candidate key transitively determining some prime attribute A. Candidate key alpha. Can we have this? Remember the definition of transitive dependency. Recall the definition of transitive dependency. What is that? Recall the definition of transitive dependency. What is that? Definition of transitive functional dependency. What was that? Do you remember? I told you that alpha, if you have alpha determines beta, determines A, where beta does not determine this, and also A should not belong to beta, A should not belong to alpha. Do you remember this? The complete definition I told you. A should not belong to alpha, A should not belong to beta. Okay, A should not belong to alpha, A should not belong to beta. This was the definition. This was the complete definition. So alpha goes to A is a transitive. This was the definition. This was the complete definition. Now you tell me, in the BCNF, can you have this? In the BCNF, can we have this? Let's assume BCNF, we have this. In BCNF, let's assume this is candidate key. Okay. And let's assume it is subset of alpha. Let's assume it is subset of alpha. Maybe some subset of alpha. Let's assume this is some subset of alpha. Okay. And let's assume here you have A. Okay. So it is looking like that it is possible. It is looking like yes or no. It is looking like that this is possible. But what is the problem here? What is the problem here? What is the problem here? This is the problem. This is the problem. This is a non-trivial FD or not? Tell me, this is a non-trivial FD or not? This is a non-trivial FD or not? Why this is non-trivial FD? Tell me. Anyone? Why this is non-trivial FD? Anyone? Why this is non-trivial FD? Anyone? Why this is non-trivial FD? Tell me why this is non-trivial FD? Why this is non-trivial FD? Because this is single attribute and this does not belong to beta. Because this is single attribute. Why? Okay, this is a very simple concept. This is a single attribute and alpha does not belong to beta and A does not belong to beta. So this is non-trivial FD or not? A does not belong to beta. A does not belong to beta. And A is single attribute. This is your non-trivial FD. So what should happen? So what should happen? So beta is candidate key. So beta is super key, right? So this beta is super key because your relation is in BCNF. Because your relation is in BCNF. Is this clear? Because your relation is in BCNF. So this beta is super key. So there is a contradiction. So beta can determine alpha. Contradiction. Contradiction. Tell me, did you get it? This complete analysis. Did you understand this complete analysis of this question? Tell me. The complete analysis. So in BCNF, can we have this type of situation? Can we have this type of situation? So this is no. The answer is no. This is the complete analysis of this question. So remember, in BCNF, this cannot happen. This is not possible. A prime attribute is transitively dependent on a key. In BCNF, this is not possible. So finally, this will be your answer. The question is asking for false statement. Your answer will be option D. Is this clear? Is this crystal clear? Like, do you have any doubt? Why beta goes to A is non-trivial? Tell me. See, tell me, if this is beta and this is a single attribute, this is a single attribute, this is a single attribute, A does not belong to beta. So can I say this is A does not belong to beta? So can I say this is, tell me, A does not belong to beta. So can I say this is non-trivial? Clear? Let me know. But relation is in BCNF. So beta has to be, this is what I am saying. This is what I am saying. This is the contradiction, Nikhil. This is the contradiction we are getting. If this is non-trivial, then beta must be super key. If beta is super key, then beta determines alpha. So there is a contradiction. So we got a contradiction. Is this clear? So we got a contradiction. So remember, in BCNF, you cannot have this type. So in BCNF, you cannot have this. Okay, you cannot have any candidate key transitively. Okay, any candidate key transitively determining prime or non-prime. This you cannot have. Okay, one by one, I'm telling you. This you cannot have. Transitively determining prime, this you cannot have. Okay. Similarly, candidate key partially determining prime, this also you cannot have. Okay, is this clear? And the same thing you can say for non-prime also. The same thing you can say for non-prime also. So transitively determining this and transitively determining this. So this type of non-trivial functional dependencies you cannot have. You cannot have, you cannot have. Is this clear? Tell me. So these type of dependencies are not there. Okay, now let's see then this question. What about this question? Tell me. This is GATE 1990 question. Which of the following statements are true? A relation database in 3NF may still have undesirable things because it may still have undesirable data redundancy because there may exist. In 3NF, there may exist. So tell me, can we have transitive dependency? In 3NF, can we have transitive dependency? Which is in 3NF, may, okay, so can we have transitive dependency? Yes, you can have. Correct? Okay, so yes, you can have. What about the next? Non-trivial functional dependency involving prime attributes on the right hand side. This is also fine. This is also fine, right? No problem. No problem. Okay, non-trivial functional dependencies involving prime attributes only on LHS. Only on LHS. Tell me, non-trivial functional dependency involving prime attributes only on LHS. Means on RHS, who is there? On RHS, who is there? On RHS, non-trivial, non-prime. On RHS, you have non-prime. That is not allowed. Yes or no? That is not allowed. In 3NF, this is not allowed. I told you. In 3NF, everything is allowed, but this is not allowed. Like candidate key, this type of, I can say this is not allowed. I can say not a super key implies non-prime attribute. Not a super key implies non-prime attribute. This is not allowed. Is not allowed. Okay, so this is not allowed. This we have already seen. In 3NF, this is the problem. In 3NF, you must not have this. So you can notice. So option C is false. Why? Because of this word only. Because of this only word. Because it is saying that prime attributes are only on LHS. Means on RHS, you have non-prime attribute on RHS. That is the problem. What about this one? Involving only prime attribute. This is fine, no problem. This is fine, there is no problem, right? Why are you getting redundancy? Why you are getting undesirable redundancy? Because of this situation, can you get undesirable redundancy? Tell me. This is my question. Because of this situation, like let's assume candidate key, or maybe you can take this, not a super key, implies prime attribute. Because of this situation, can you get unnecessary redundancy? Can we get undesirable redundancy? Undesirable data redundancy means data will be redundant. Okay, so because of this, so the answer is yes. The answer is yes. Let me take one example. Consider this ABCD. This is a relation, and let's assume AB determining CD and CD determining AB, A determining C. Now here what will happen? See, this is in 3NF, right? Correct? This is in 3NF, but still you can notice this type of situation. Can you notice what is happening here? Tell me what is happening here. This is not super key. Can you notice this is not super key? And can you notice this is a prime? Not super key. This generates prime. So there is a redundancy. This can create redundancy. This can create a lot of redundancy. Can create a lot of redundancy. What is that? How can it create redundancy? Just think about it. Just think about it. This is your table ABCD. Okay, and your A determining C. Now notice what will happen. Let me write it here. Let me write like this. Now notice what will happen. See, whenever I repeat this, let's assume there are 10,000 records. Okay, let's assume there are 10,000 records. Let's assume there are 10,000 records where you have two. Then automatically what will happen? Automatically what will happen? This is redundancy or not? Can you notice unnecessary redundancy? Just think about it. Like for example, if you write this every time, just think about it. Jaipur determines Rajasthan. If you write this, okay, let's assume you write this 10,000 times Jaipur, Jaipur, Jaipur. This Jaipur, 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 you write it 10,000 times. Let's assume you write it 10,000 times. Then this is redundancy or not? If you have to write this again and again, if you have to write this again and again, this is redundancy. This is redundancy. Unnecessary. This is unnecessary. The same data you are repeating, repeating, repeating. What is the better solution? What is the better solution? What is a better solution? The better solution is just put a different table. Just create a different table. So what is the solution? A solution is very simple. Just create a different table where you have district and where you have state. Just create a different table. Now there will be no such redundancy. Now it will come only once. This data will only store one. You will store this data only one time. This data will be stored only one time. Correct? Okay. So like this. Ekta is asking, can be repeating in any functional dependency? Yes. In any functional dependency, this will happen. Apart from, except in BCNF. If your LHS is super key, then it will not happen. Ekta, why? Tell me. Why? Tell me. If your LHS is super key, then it will not happen. If your LHS is super key, then it will not happen. Why? Because it will not repeat. Because it will not repeat. The LHS will not repeat. So the RHS will not repeat. Yes or no? LHS is not repeating. So the data will not repeat. That we will see in the next class. In the next class, we will see. May repeat some tuple. Why? Why? Tell me. If your LHS is not repeating, then RHS will also not repeat. You are super key. LHS is super key. If you have super key, tell me. If you have a table R, A, B, C, D. Okay, tell me. And let's assume you have this AB determining CD. Let's assume you have this. Or maybe you have something like this. A determines BCD. Now notice this is super key. Now it will not repeat because it's super key. So this cannot repeat. Yes or no? This cannot happen. Agree or not? This cannot happen. Yes or no? Is this clear? It will not repeat. That is the point of super key. What is the point of super key? In BCNF, what is the point of super key? Tell me, what is the point of super key? So it cannot repeat. Super key row cannot repeat. Super key cannot repeat. So it is not repeating. So because it is not repeating, so now tell me, is this redundancy? Is this redundancy? Tell me, is this redundancy? Anyone? Is this redundancy? This is not redundancy. Why this is not redundancy? Because this is the unique data for this. This is the unique data for this. This is the unique data for this. It's like this is not redundancy, right? For example, if I say Kota, Rajasthan, okay. If I say Jaipur, Rajasthan, will you consider this as redundancy? Tell me, will you consider this as redundancy? This is not a redundancy. This is one information. This is another information. This is one piece of information. This is another piece of information. So this is not a redundancy. Okay. Now, so tell me here. So is this question clear? What is the answer? So which statement is true? For this question, which statement is true? The answer will be this is true, and this is true. Okay. Answer will be ABD. So these are some gate questions that we have seen. And this is your chapter. The remaining questions we will see in the next class. Can you tell me the answer for this one also? Okay, let's quickly see the answer for this. This is GATE 2012. Which of the following is true? Every relation in 3NF is also in BCNF. This is false. This is false. This is true. Every relation is BCNF is 3NF. This is true. What about this? No relation can be BCNF 3NF. This is false. And what about option B? A relation in 3NF if every non-prime attribute of R is fully functional dependent on every key. A relation in 3NF. A relation is in 3NF if every non-prime attribute of R is fully functionally dependent on every key. Tell me, this is the definition of 2NF, right? This is false. Why? Because this is the definition of 2NF. See, can you give a counterexample for this? Can you give a counterexample where you have 2NF but not 3NF? Very easy counterexample you can give. For example, I can consider ABCD. This is your relation. Now, what you do? Consider this. AB determining CD, C determining D. Okay, let's consider this. Is this in 2NF? This relation. What are the candidate keys? Candidate key is AB. This is the candidate key. So if you notice that this AB determining C, this is full or not? Tell me, this is full or not? Is the dependency full or not? This is full dependency. This dependency is full dependency. Also AB determining D, this is full dependency. So can you notice that? Can you notice this is also candidate key and this is non-prime? So here can I say that? Tell me, can I say that every non-prime is fully dependent on every key? Can I say? Can I say here every non-prime? Can I say every non-prime is fully dependent on every key? Correct? Every non-prime is fully dependent on every candidate key. But still this is not in 3NF. Can you notice this is not in 3NF? Yes or no? This is not in 3NF. Is this clear? Because this is the violation of 3NF. This is the violation of 3NF. Is this clear to everyone? So you can notice this statement. This statement is false. If every non-prime attribute is fully functionally dependent on every key, then I can say, then it will be 3NF. So this statement is false. This is the counterexample. Here you can notice every non-prime attribute is fully functionally dependent on every key, Still it is not in 3NF. So this statement is false. Okay, is this clear? What will be the correct statement here? If you replace this with 2NF, then it will be correct. Correct? If you replace this with 2NF, then it will be correct. So this statement is, so the question is asking true statement. The answer will be option C. But remember, if you replace this with 2NF, must be 2NF to be correct. Okay, so this is your chapter, normal forms. Tell me, did you understand all the concepts? Did you understand? Like crystal clearly, I have explained every concept in a very, I can say, all the variations, like whatever variation has come to my mind, whatever variation I found on the internet, I've taken it. So tell me, did you clearly understand this? You can work it out. Okay, just work it out. Just study this. This is a very simple topic. Let me tell you. This is a very, very, very simple topic. This normalization, normal form, BCNF, 2NF, 3NF, okay, 1NF. This is a very simple topic. Very simple topic. Once you understand this, many good questions you can solve. And if you have those misconceptions, those misconceptions, like those are wrong concepts, like 2NF cannot have partial dependency, 3NF cannot have transitive dependency. Those are wrong concepts. And there are gate questions. Remember, there are gate questions which are telling you that those are wrong concepts. In gate already there are questions which are telling you that those are wrong concepts. I don't know, still you will find, okay, let me tell you, it is true, and this is the, I can say, this is the this is unfortunate in the coaching industry. You can check it out, check all the notes of your friends who are learning from non-standard resources, who are learning from some random YouTube videos or learning from some coaching institute. Check their notes. So you will find these type of, all these misconceptions you will find in the normalization. In the partial dependency definition, you will find the misconception. Partial dependency definition, transitive dependency definition will be not there. Let me tell you, transitive dependency definition will not even be there in the notes. There will be no definition of transitive dependency. They will use the word transitive dependency definition. They will use transitive, but the definition will not be there. Okay, and 2NF, 3NF, all these misconceptions, all these wrong concepts will be there. So anyway, you don't have to worry about it. After the GATE exam, you can do that. Okay, after the GATE exam, you can maybe for 5 or 10 days, you can check it out. Okay, and once you check all the resources, not NPTEL, because those are the standard resources. We are also learning from NPTEL. We are also learning from like whatever we are teaching you in the Go classes, we are learning from standard resources. We are learning from NPTEL, from MIT, from all the standard resources we are learning. Okay, but all the non-standard resources I am talking about, all the non-standard resources I am talking about. Okay, so you can check it out, and once you check it out, then you then after that you can recommend Go classes to the students. Okay, okay, so like that, because it happens, they will teach you in a very easy manner. Nowadays, all the teachers, they are very experienced, so they know how to teach you all the easy concepts in easy manner. They will teach you easy concepts in easy manner, and the students will think, oh, so he's a god, because he is teaching you easy concept in easy manner. They will not even touch the hard concept. Hard concept they will not touch, and if they touch the hard concepts, they will either teach it wrong, or they will make you by heart. They will give you a table, just by heart this table, just by heart this formula, by heart this procedure, by heart this theorem. Okay, so something like that. Anyway, so forget about that, all these things. Okay, anyway, so anyone has any doubt, let me know. Anyone has any doubt? I will upload the notes immediately. Okay, this Ekta, your doubt I will clear in the next class. Okay, this redundancy, 0% redundancy and all these things, I will clear in the next class. This, your doubt will be clear, don't worry. Okay, okay, thank you, bye.